Hello everyone, my name is Matthew Wilson and this is our introduction to our sequential circuit 3, which is going to be a gumball machine. So first we're going to start with our basic 5 steps that we have in order to create a sequential device. The first one being our state diagram. So this one here is quite simple. We only have 3 states. We have 0 cents, 5 cents, 10 cents, and then at 10 cents going in, it's going to reset back to 0, but we have a star here to represent this is when it's going to give us our gumball. So the ones move along pretty well, and then our zeros, obviously if there's nothing being put into the machine, it's just going to stay at that current state. Next will be our state table. So again, pretty simple, pretty structured following state table. And then we have our K-maps, as well as our derived Boolean equations for t1 and t0 and our z-value as well. And once we're done with these 5 steps, we can go ahead and create our sequential circuit in Logisim, which I will go ahead and show you guys what I've created now. And just to kind of go back real quick before I show you guys the circuit, I want to describe the importance of why these steps are so crucial in our design process. So first is our state diagram, and this is essential into everything. The steps 1 through 5 that I've previously discussed kind of fall into each other like stepping stones. So with your state diagram, you can clearly see the visual of why and how the circuit will move. So every 1 values will move to 5 cents, 5 to 10 cents. 10 cents will then give us our gumball, and then reset our count back to 0. And then obviously the zeros just leave it where it's at. This information is crucial though in our state diagram to create our state table as well. Our Q1 and Q0 ultimately affect T1 and T0 of our T flip-flop. And basically it's just our state table is again stepping stones into why and how we can create our K-maps, which then we can create our derived Boolean equations from there, as you can see here, which then our Boolean equations help us to create our circuit, which I will show now. Okay, so over here in Logisim, we have our 3 little equations from our derived Boolean equations here that we've went ahead and built within our Logisim, our T0, T1, and Z. We have our testing outputs here, Q1, Q0, and our gumball. We have our inputs here, our clock and our X or our nickel. And then we have kind of the heart of the circuit, which is our 2 T flip-flops and our D flip-flop in order to see when we're actually getting the gumball. So to go ahead and demonstrate the circuit, what we'll do is we'll go ahead and turn on our X variable, which is also our nickel. Start the clock, that's 5 cents into the machine. 0, 1, we can interpret that as 5 cents. One more clock cycle, we're at 10 cents now, or 1, 0. And then on the next clock cycle, we will go ahead and get our gumball. And then you see our count resets back to 0, just like our state diagram showcased. And then you can see that we reset at 0, no gumball was dispensed. And then once we keep going, the clock will just restart infinitely until we get however many gumballs we would like to have. And also comparing our state diagram, the 1s and 0s. So if we had 10 cents in here and go ahead and not input a nickel and the clock keeps running, obviously nothing would happen. And the reason this is a melee machine is because of our outputs are directly determined by both its current state and its current inputs. So as you see, our X affects our outputs, which tells us why it is a melee machine. And that is all I have for you guys today. Thank you.